Today's lesson was about perfect squares. So what does it mean for something to be a perfect square? It can be a number or an expression that can be multiplied by itself. So I'm sure you're familiar with like perfect squares as numbers. They say that, or most math teachers will make you memorize the first 12 perfect squares. So look up here and I'll look at the screen. And really you kind of should recognize what's the first 12 perfect squares, but any number you can type in your calculator, like put it under a square root symbol, and if it gives you a non-decimal, then it is a perfect square. But the first 12 perfect squares, so like 1 squared is 1, 2 squared is what? So you use the calculator, but this is where like I need you to pay attention. 2 squared is what? 3 squared is 4 squared is 5 squared, 6 squared, 7 squared, 8 squared, 64, 9 squared, 10 squared, 11 squared. Good, and 12 squared. Okay. These are our first 12 perfect squares that, like, if you see them, they're our most like easily identifiable perfect squares. Of course, like you can do 13 squared, 14 squared, like you can do any number and square it, but you probably don't have them memorized. So just if you ever want to check if it's a perfect square, put it in the calculator under a square root symbol and it'll give you a whole number in the perfect square. Now, we're not just doing numbers anymore, we're doing like expressions too. So what would be the square root of x squared? Yep, x. And that's, honestly, I feel like that's like the highest we'll go in this class. Like, I don't think we'll ever have to like, because we're only doing quadratics right now, which the highest is x squared anyway. But say you needed to find the square root of x to the 4th power. What's the square root of it? X squared. So any variable with a positive integer is also a square, like a perfect square. Although we're mostly just going to be dealing with x squared. All right, now one of the key skills, and it's on your tests, is recognizing quadratic equations that are perfect squares and being able to solve them when they are. And when they're written in different forms, still be able to tell that they're perfect squares. So it's really easy. Here's one way. Like if it's an expression squared, that's a perfect square. If it's the same exact parentheses multiplied by itself, that's a perfect square. So factor form is pretty easy to tell. But you'll also have some problems in standard form that you'll need to check if they are perfect squares or not. So let's see on this page. We didn't get to this in the notes. Not like we really needed to, we kind of already talked about it, but here's like a good test question. Which of these quadratic expressions are perfect squares and which are not? How can you tell? So there were some things that we talked about that people will memorize, like, oh yeah, that's a perfect square trinomial because it's a squared plus 2ab plus b squared. Personally, I don't like memorizing random things like that, although that is something you could use to identify if it's a perfect square pretty easily. So like, is this a perfect square, x squared? Again, I need you all to pay attention. What's the square root of x squared? So it is a perfect square. Is 8 a perfect square? So you could say this one is not a perfect square for that reason, because perfect square trinomials have perfect squares on each end. and the middle term is 2 times the square root of the first one times the square root of the last term. Again, I don't like that one as much as I like factoring. If I were to factor this, 8 would go on top, 4 would go on the bottom. What multiplies to 8 and adds to 4? Anything? I can't think of anything wrong. So, nothing. I think this one might even be fine. But it's definitely not a perfect square, because if it was, we'd have the same number here and here to make it happen. And right now we don't. See the next one. Try factoring it, is what I think is the easiest way. What are 2 numbers that multiply to 144 but add to 24? 12 and 12. Because this is the same exact number, same sign and everything, this is considered a perfect square. Because the same thing times itself, right? I could even write it as x plus 12 in parentheses squared. So that's, to me, I think the easiest way you tell that is something you should already know how to do. Or you could use this way if you want. Okay, so think about it, don't say it yet. Would this one be a perfect square? Okay, what do you guys think? Yes or no for that one? All right, so what multiplies to 16 and adds to 6? Anything you can think of? When it's multiplying to a positive 16 and adding to a positive 6, I can't think of anything, especially not like where it's the same number. So I would go with this one is not a perfect square. It might not even be factorable. But anyway, over here, last one we'll try 2 numbers that multiply to 400 but add to negative 20. Or not negative 20, negative 20. So if it is a perfect square, then I would have the same number here and here. Do we know like the square root of 400? Can we look that up if we go? Okay, now is there a way that I could put like the same 2 numbers and make it multiply to the top and add to a negative 40? What can I do to make it multiply to the positive, add to the negative? Make both of them negative. So is this last one a perfect square? Yes. This one is a perfect square because I can write it like this in the factor form. So that's how you can tell. It'll be written in different forms. My suggestion would be to factor it, see if it gives you something that's like the same exact parentheses. Or you could try the other way I mentioned, but see what's easier for you. I like memorizing fewer things. So the practice today is lesson 11, but of course, like if you've been slacking on your other practices, then definitely do that before you just give yourself this time. The same thing with the coloring activity, like that was worth assessment points, like you could work on that more and submit it for more points. Yeah, if I keep noticing, like, for example, certain people keep not doing their practice, even though they're here every day in math lab and in algebra, like, I'll just make you sit like right here and I'll just watch you work. Make you put your phone like away from you so that you can get your work done. There's no reason, especially when I help you with like at least half of it every day, there's no reason you shouldn't have submissions in for that. So any questions? Okay. And it says to rewrite the perfect square expression into standard form. And you're basically just filling in the numbers. So to go from factor to standard, we did that in unit 6. So basically you just need to multiply it out. You cannot just distribute the exponent like and apply the power rule. It doesn't work when there's like a plus or minus going on in here. So you have to expand it. Remember that exponents tell you to multiply the base by itself. So it's 5 times, or 5 minus m times 5 minus m, like that. And then you could FOIL, double distribute, box method, whatever you like better, and then get your answer. I'll show you box method. So 5 minus m and 5 minus m. What's 5 times 5? What's 5 times negative n? So anyone can answer 5 times negative n is close, negative 5n. 5 times negative n is negative 5m, and negative m times negative n is m squared, a positive m squared. Now, once you've done that, filled in your box diagram, you definitely want to write it in descending order of exponent, like our normal standard form. So I'm gonna write the m squared first. Then I have some like terms to combine with negative 5m plus negative 5m. So that would be multiplying. At this step, we add them. So negative 10m, and then we have plus 25. For some reason they use x's, so just like translate the difference there. The coefficient in front of the m squared is 1, and you can't just leave it blank. The coefficient in front of the x term is negative 10, and then my constant is 25. They should have used m's, but it's fine. You can figure out what they mean. Questions on this one? Questions on any other? And into standard form, so first step is to expand it, so make it n plus 7 times n plus 7. I showed you box method already, so maybe let's try foiling, but whatever gets you the right answer at the end of the day, it doesn't really matter. So multiply the first terms in each parentheses with n times n. Good, then multiply the outer terms, n times 7 is good and it's positive, so plus 7n. Inner term, 7 times n is 7n, and then last terms, 7 times 7 is 49. Combine like terms, it usually tends to be like your linear terms, the ones that would be like just x or just n. 7n plus 7n is 14n, and then nothing else is fine. So then to fill in the blanks the right way, in front of the x squared, the coefficient is a positive 1. In front of the x term, the linear term, it's a positive 14. And then my constant is 49. All right, any other questions?